Hi, folks. Welcome to today's live stream. My name is Federico, and the subject I prepared for you today is related to making finger joints. We've gotten a lot of questions and requests about how to make different types of boxes, and we have a few box templates like this one. This is the kind of very basic one. And people have been wanting to do remixes or to make changes to it. And we made a few videos explaining how to do things, but it seemed like it was time to release what we want to call the finger joints kit, which is like just the basic, like bare bones things that you need to join kind of two flat pieces together. And that is like the building blocks for all of the boxes, all the box templates you have made. So I think I want to explain to you how to like do very basic joinery with the finger joints. And that probably is going to help you understand how to modify other boxes later, or even to how to make simple projects. So cool. Yeah. Thanks a lot for coming, and feel free to post questions in the comments. So this is the finger joints kit. I'm going to publish the link in a moment. And so unlike other templates, we're calling this one a kit because you don't get like something that you can download like immediately. It usually has like some instructions on how to use it. I'm going to post a video about how to use it. And so to start using it, you need to open it in the Cuttle editor. So there's the button up here. And so you can hit click. You can click here to open in the Cuttle editor. And so for now, it's like a very bare bones thing. And because I'm going to be making some changes, and probably if you're going to start a project with this kit, you want to copy this project to your project. So when you click this, it creates a private copy on your projects folder. So I'm going to rename it so I don't get confused. I'm going to call it the demo. And so let me show you what the idea is here. So as you can see, it has very few parameters. It has only 3. So material thickness, kerf, and tab width. And that is intentional because we wanted to like not have all the parameters that say all the other boxes have. So if we compare it here with the open box with finger joints, look at all the parameters this one has. So this one has like more things, the width, the depth, the height, and other things. So sometimes when you want to like just do something simple, you don't want all this stuff, and it has a lot of components, of course. So let me show you like the basic functionality. The idea here is that like sometimes you just want to join, say, 2 pieces of material. So I'm gonna kind of drag 2 rectangles, and I'm gonna make them 1.5 inches, just so they're a little, they're big enough to show you. I'm just gonna duplicate this one. And so my idea is that I want to join these 2 rectangles with the 2 edges. I want them to be joined. I actually kind of went ahead and cut them just to show you the idea. So I have these 2 rectangles that are that size that I just made, inch and a half. And so the idea is that I want to join them at a 90-degree angle, kind of like these, kind of like so. And so I want to have like some feature here on the edge that allows me to like, connect them together. And so if I go back here to my, the basic, most easy way to do it is there are these components here on the side. So you can see there are like 3 components. And so one is called finger joints, the other one is called finger joints outer, and the other one is called slots. I'm going to concentrate on the first 2. So the easy way to do it is to just grab the finger joints. And as you can see, they work as a sort of component with 2 points. So I can like grab, the points. And the cool thing you can see is that the longer it is, the more tabs it generates. And of course, the shorter it is, fewer tabs. And the tabs just accommodate to whatever distance you make it. So if I want something on this edge, I want to snap this point to this corner and snap this point to that corner. Let me zoom in. So in order to have like a mating edge that fits this one over here, I need to grab the other one, because if I were to do the same finger joints, let me just do it to demonstrate. So I'm going to put the point in the corner, the other point in the corner. Then I would have two kind of chunks that don't mate together. These two wouldn't like work. So I need to use the other one. So let me delete this one and grab the one called outer. So you'll see it when I use the one called outer. I'm going to snap it to the corners. Then I get two sections that just mate each other. So these will go into here and this will go into here. And that is like the basic functionality. So if you have just two pieces and you don't want to do a lot of things, you can simply drag the finger joint, the two mating pairs, and then importantly, the two edges need to be the same size. Let's do a quick thing I want to do in order to prototype things, is that whenever I'm working with any material, I like to just, I want to start by measuring the thickness. So I'm going to use the calipers here. So I'm going to take a few. So yeah, I'm getting like mostly 0.117. So that is my material thickness. And then I want to start with that. So if I go back here to my project, you'll see that the material thickness can change here. And so the only thing the material thickness affects is the length of the joints. So that's not going to affect the fit so much, but it's important to have them be the material thickness, because otherwise they would kind of like either stick out too much or like not connect enough. So let me explain that here. So I'm going to enter the material thickness that I wanted, 117. And then if I change the tab width, that determines the width of the tab. So let me make it smaller so you can see. So that makes it smaller. And then the finger joints kit tries to fit as many tabs as it can in a given edge. So if I make it even smaller, you can see that I get like multiple tabs. So I'll do it like this just to like be able to show you. So another thing to explain is that like these finger joints kind of retain the size of the shape, and then they just add the joints to the corner. I think this is easier to visualize if I show you. So like if I'm joining these two pieces, like I'm not gonna like butt them together like these. Actually, when I add the finger joints, the joints themselves get added to this corner. So like if I have these two pieces and I just touch the edges, you can see that the corner is kind of hard to hold. The corner itself is like a sort of void that gets created. But that void, it's the void that gets filled by the joints. That's just like a little subtlety to like understand there. So if I wanted to just kind of go ahead and like send this to the cutter, I would want to join them. So I can select this one, and I can simply use the Boolean union, and same with this one, Boolean union, and I'm ready to go. I can simply like send this to the cutter and then cut them. And then the cool thing is that like now, all these parameters still function. Like the material thickness is going to change those joints to be the height that we want. And even the tab width can be changed, but I'm going to keep it the same for now. So I actually went ahead and cut these. So these were my original pieces. Then I went and cut the ones where I added the joints. So these two. So I can go ahead and try it out. So I get this kind of fit. So yeah, what I was trying to explain before, maybe I can explain it better with these two pieces. So you can see how the joints are filling that corner. And then the size of the original rectangle is still kind of matches the size that I get, here and here. That's just to say that with the finger joints, you're generally kind of taking into account the inside dimensions of your box. But the way I just did it has a number of disadvantages. So it's my job to convince you that this isn't the best way. So the first disadvantage is that like now that I did this, and if I wanted to change the size of those rectangles, let's say I can like go here and change the size. You'll see that something breaks. Like the joint stays in place, and then things didn't work out the way I wanted. This is the one. So if I try to size it that way, it doesn't work. If I try to size it the other way, where like I do things like these, you'll see how the joints stretch out. And even if I size this one similarly, like to the same length, the joints might not match. It might be like a little off because they got stretched in kind of like a weird way. So this isn't the ideal way to do things if you want to resize your project eventually. If it's like a one-off kind of thing where you're just trying to mate two pieces, then like it might be fine. But let me show you the better way. So I'm just going to create another component just to explain. So here we go. So I'm going to do exactly the same thing again. I'm going to grab two rectangles. I'm going to grab one rectangle. I'm going to make it 1.5 inches. And I want to duplicate that one. So I have a second one. And so now there is an easier way to create the finger joints, which is as a modifier. So I can select one and go to the modify menu. And there at the very bottom, you'll see one that is called replace edges. So as soon as you apply it, it looks like nothing changed. But let me show you how it operates. So this rectangle has 4 edges. So it has 1, 2, 3, 4, and then here I get this sort of list of things that I can apply to those edges. So this list is going to determine what each edge gets. So I'm going to start typing something. I'm going to start type finger joints, which is the same name of this component that I just used. So if I tap finger joints, you'll see how the edges kind of change into finger joints. But I'm going to type everything just to explain it. So I'm going to type line and then line again. So what's happening here with these replace edges is that it is replacing the edges for whatever I specified here. So this edge is a line, meaning nothing changed. This edge is a finger joint, this one right here. And then this edge is a line and this edge is a line. So as you can see, these replace edges is like kind of doing things sort of clockwise, replacing it for whatever I specify here. So just to show you, if I were to replace this one for finger joints, you can now see sort of the correspondence. You can see that this line corresponds to this one, this finger joints to that one, this finger joints to that one, and the last line to that last edge. But I don't want that to be a finger joint, I want that to be a line. And so now for the mating one, I can select it, I can apply the same modifier, I'm going to apply that replace edges modifier. And so now I need to sort of count. I want this one to be aligned, this one to be aligned, this one to be aligned, and this last one I want it to be the finger joints outer because it's the one that matches. So let's do that. So I can type line, line, line. Nothing has changed, and the last one should be finger joints, and I can just select the one right there. So now that I get the finger joints outer, it should, because the edges are the same length, that's very important, they should match. That seemed like a little bit more work initially once you understand it, but notice that it saved me the need to add the weld modifier. It simply replace the edges. And additionally, if I need to change the size of anything, so for example, if I wanted this to be 2 inches, I can change it to 2. And notice how the finger joint edge just kind of sized appropriately. And similar with this one, if I make this one 2 inches, then it also gets sized appropriately. So meaning because the edges are the same size, they should match kind of nicely. I think I can even size it like this. Yeah. So if I size it like that, it should also follow that it's going to add as many tabs as it can fit in there. So I think that's the basic idea. So my job is to convince you that it's nicer to use replace edges if you're going to be working on projects like this one. Let's try another example with a different shape, just to kind of reinforce the idea. I guess the explanation is that, like, when you want to make two things, you want to sort of select make the edges the same size, and then you have to sort of do a good selection of like what matches with what. What I mean by that is that if we go and look at the open box with finger joints, we can see that it is constructed in that fashion. So let's just take a quick look to show you. So if I go look at the bottom of the finger joints box, you'll see that the bottom is a rectangle right here, and that to that rectangle, the replace edges modifier has been applied, and it just has the finger joints all around it. So that gives you a way to understand this particular template. Now, if I go look at the, let's see, at the back of the box, that one is also another rectangle to which the replaced edges has been applied with a particular pattern. So you can see that it has a line finger joints outer, which is this one, finger joints outer, and so all of them are the outer type. And so by kind of placing them in the right order, then you get to be able to assemble it like these, to have these kind of like mating edges. I want to show you another example, because as long as the edges are straight, then you should be able to use them. So I was thinking a triangle. So if I want a right triangle like these, but it's also 1.5, let's make it so it's big enough. And another triangle like this, let's make it 1.5. I can do the same business. I can apply the replace edges. So let's do that. So I'm gonna replace edges on that one. I'm gonna replace edges on that one. Then I'm gonna get this one. I might struggle a little bit with the pattern, but let's do it. So these replace edges. So I know I want one of them to be finger joints. Something you might notice also is that if the number of edges here is not the same as the number of edges on the shape, they just sort of loop around. So there is no need to have like precisely the same number of edges on the list over here, but sometimes it helps. So it helps, for example, in this case, if I do 3 edges, I can sort of find out what is happening. So I know that it starts with line, then finger joints, then line. So maybe I just want to change the order. Let's say maybe I start with finger joints. With the triangle, it's a little funny because it starts right here, finger joints, then line, then line. So then with this one, let's look at it. Remember that I want the finger joints outer on this one. I don't know if this is gonna work, finger joints outer. So this is the thing where I meant like it loops around. If you have a single type of finger joint, it will just loop around all the edges, placing the same type of joint on each edge. But as soon as I start typing something else, then things start getting replaced. So what if I do line, line? No, so I think it needs to be line at the beginning. Nope, got that one wrong. So I get line. Oh yeah, I did mention I was gonna struggle with this one. Let me see, so I need to change the order. Finger joints. Oh, I see. Okay, I think I got it. Yeah, so that makes sense. So now that I have these two, I can actually send them to the laser cutter. And let me show you the ones that I cut for that. So here we go. we have this one and this one. And so I'm not sure that this is like the most useful thing to make, but I just wanted to demonstrate that I could create the, I could add the edges to, a shape that was in a rectangle. I think like boxes are all based on rectangles, so you'll see that quite a bit. Cool. So I think I wanted to try and assemble something that was a little bit more complex or like even more useful. So my next idea that I wanted to show you is that I wanted, part of the struggle with designing things with finger joints is that in Cuttle, we are designing, we're looking at things in a 2D flat kind of screen, but the things that we're making end up being three-dimensional. So there is definitely like a sort of back and forth between thinking three-dimensionally and thinking in flat, thinking on a flat surface. So sometimes I need help. So I end up making often little paper models. So I made this paper model. So because the next thing I wanted to design was like a sort of little shelf. So the idea is that I have, I could have this as a little shelf that like kind of can hang somewhere. It has like a little angle. But the easy way for me to visualize it was to actually make a little paper template, because with the paper template, I can actually, set it flat, then I can kind of unfold it, and then I can sort of think about the type of shapes that I need. I don't know, some people, I could use paper templates. You could do it you could sketch it out or something, but I'm using this one just to sort of explain what my idea is. So in order to make this little shelf that has 3 pieces, because I've just been making things that join only 2 pieces, I wanted to think about it this way. So I know that I need the 2 triangles, I need a rectangle, and I need this edge to match this edge. And I need this one to match this one. So that is like my assignment to show you. So let's go back to the Cuttle here. So I think I can sort of apply the things that I've been showing you. So let me, I can delete these. So let's start with the rectangle. So I'm gonna try like a rectangle like so. Let's make it 3 inches long, and then let's make it 1 1/4. It's gonna have to be the width, yeah. So that rectangle is gonna have a couple of triangles on the sides. So let me search for the triangle. I'm gonna use the right triangle because these are so easy to resize. And I'm gonna use this other right triangle. And so I need to resize these edges to match, to be the same size. So I simply need to make it 1 1/4, 1.25 inches. So that way the edges are the same. And same with this one, 1 1/4. So I have the same edges. Now I'm just gonna separate them. I'm gonna start with the finger joints on the sort of base of the shelf, the kind of horizontal part. So I'm gonna go ahead and apply that finger joints modifier, the replace edges modifier. And so let's type, I wanna use the outer finger joints for this one. So I'm gonna type finger joints outer. I got lucky, but the looping probably makes sense in this case because there are 4. So what's happening is that this is line, the first one, then it goes to finger joints, and then it loops around. So it loops around back to line and then to finger joints outer. So that one kind of makes sense. These would be the equivalent or the same thing as typing, line, finger joints outer, line, and then finger joints outer. So same thing, maybe more readable. And then on this one, I want it to be like the one I made previously. So I'm going to modify, replace edges. I think that one was like finger joints, then line, I got that one right. So as you can see, I got the edges matching. And then with this one, I can do the same. Struggle again with the order, finger joints, line. No. Okay, I got it. So I got those two edges matching. And once again, the beauty of using the replace edges is that like eventually if I want to change my shelf, I can like, change the dimension. And as long as I match the dimensions of the shelf, let's say 1.7 to the dimensions of the triangle, let's say 1.7, these two should do the trick and join them, join. But I did go ahead and cut this original size just to show you. So here's my shelf. So this is how I orient it, like so. So yeah, the basic idea was like so. So I can go ahead and like try and join it. I think that I got a good fit right there. I haven't tried joining this one. Kind of a satisfying click on that one, and that is my little shelf. You can see it right there. So I think one thing to mention about that is the same thing I was mentioning before, is that sometimes when you're creating a project with finger joints, the dimensions are going to be a little tricky because you're always kind of adding the material thickness to some side. So remember, I sized these, the length of this one was 3 inches. So that means there are 3 inches between this edge and this edge right here. But the total length of the shelf now has, material thickness added, material thickness twice because it's here and here. So sometimes when you're sizing these things, you kind of need to account for that. That's like an extra thing to sort of think about. So yeah, I think that's kind of like the general overview on using the finger joints. Of course, I didn't use any parameters here for like making different things, but you can see how you can like build things up as you go. And one particular one I did not mention, but I have a couple of minutes to mention, is the slots. The slots kind of operate pretty much the same as the other two, but you can use them in a sort of slightly different fashion. So let me show you. Let me do a quick example of the slots by creating another component. So the slots work like this. The same rules apply. The edges need to be the same length. So let's say if I had like let's say like a 1.5 rectangle or square, and I wanted to join something that is like right in the middle of the rectangle, like right here. Then I would use those slots. So I could like use it kind of like the way I showed you before. I can like grab it. It has 2 points. Then I can place those points where I need them. So I'm gonna place 1 point here. Struggling with my mouse. So 1 point here on the midpoint and 1 point here. And then another rectangle, of the same size. I'm gonna just duplicate that one. Should have the finger joints outer. This is what matches the slots. No, sorry, I'm wrong. I'm wrong about that. The slots match the finger joints, the regular. So finger joints. So let's place the points where they need to go. And then, I could use replace edges or, Boolean union in this case. So these ones should match that one. And the end result there should be something like this one I just created. So different size. Maybe I made this one wider. But anyway, so you get the slots in the middle, and then the finger joints, the regular, will match that. That's kind of like when you want to join things in the middle, not on the edges. So there is a lot to explore there. That finger joints outer gets used in this particular box, which is let's look at it. By the way, if you want a reference for what mates with what, here in the README, you'll find it. There is this mating pairs. You can get a sense for what matches what. Then at the bottom, we added all the things that are built with the kit. But I was going to say that the box that is called Reinforced Open Box with Finger Joints is built with those slots. If we look at it real quick, I'm going to open it in the editor. You'll see that the front right here, the way it was done is that it has the replace edges to do the two edges on the outside, and then it has the slots kind of like strategically placed where it needs to be. The finger joint slot has like a neat feature, which is when you click on it, it has an offset. Sometimes you need to offset it from the edges. So that's cool. So I think that was the basic idea, the kind of introduction to like how to use these. It can probably give you enough to like get going with like if you have like simple projects that you want to make. But it also gives you probably enough to like understand a little bit of the structure of all the other boxes if you want to modify them. So cool. Thank you so much for watching. I really appreciate your questions and your comments over there in the chat. And I hope this was helpful. I will see you in the next one. All right. Bye.